Okay, so I know some things. The first thing is that the height of the ball at the end of the video is 0 because it's not on, it's on the ground. It's touching the ground. It's 0 feet off the ground. The amount of time that it took was 1.11 seconds, and I know that the initial height was 5 feet because I threw the ball from my shoulder, which is about 5 feet off the ground. So what we're going to do is we're going to solve for v naught, or the initial velocity. So here goes. I need to figure out what this whole thing is, and then, so let's figure that out. So I'm just literally going to type in 1.11 in my calculator squared. I get 1.2321, multiply that by negative 16, and I get negative 19.7136. And then I'm going to rewrite. I'm going to write 1.11 v naught though. Okay, so this is what I have. My like terms now are this, whoops, this, and this. So I can add those together, and I get negative 14.7136 plus 1.11 v naught equals 0. Okay, so then I need to solve for v naught. So I have to add 14.7136, and I get 14.7136 equals 1.11 v naught. Okay, divide both sides by by 1.11, and I get v naught is 13.2555. Okay, velocity is measured in feet per second in this example, and for all the examples we're going to be doing this unit. So my velocity is here. I can use that 13.2555 feet per second in my equation right here now. I suppose this should say h of, never mind. I suppose this should say something different. This should say h of t is equal to negative 16 t squared plus v naught times t plus h naught. I know these things now. I know all of these things. I know velocity, initial velocity, and I know initial height. So I'm going to rewrite. Okay, so then now this is a quadratic, and it's a function because I can put values in for t. This graph is going to look something like this. What I'm trying to find is the highest point of the ball, and that is the vertex right here. So we need to find the vertex. To do that, I need to do negative b over 2a is the x value, or for our purposes, because the inputs are t's, they're times here, that's going to be our t value. And then the height is going to be the output when you put that value in. So I'm going to write h of negative b over 2a. This should look really familiar at this point. So let's determine what is our height. So negative b over 2a is going to be negative 13.2555 over 2 times negative 16 I'm just going to throw that all in my calculator, negative 13.2555 divided by, I'm just going to write negative 32. And I get 0.41423. I'm going to try to use a lot of decimal places here because the more decimal places I use, the more precise my answer is going to be. And then I'm going to take this and put it back in for t here and here and simplify. So negative 16 t squared plus 13.2555 times 0.41423 plus 5 will give me my answer. I'm going to pause the video just for a second so that I can just type that in my calculator and give you the answer. And my answer is 7.745 feet. Okay, so that's like pretty close to 7 feet and 9 inches. Okay, this makes sense in my head because if I go back to those pictures, the ball went only like not that much further above my head. So this kind of makes sense in my head, and we got to make sure that those answers that we're getting out of our problem make sense in context of the problem. So this makes sense. The maximum height of the ball is 7 3/4 of a foot. It happened 0.414 seconds after I threw the ball up in the air. You're going to have another video of me throwing the ball up in the air in a different place in the building. I know this is super exciting today, but here's what you need to know. You need to determine the initial height and you need to find the time it takes for the ball to hit the ground after I throw it. I'm going to lead you through finding that in the next video, and then you're going to calculate the initial velocity and the maximum height of the ball on the next two draw its.